So, example 4, solve z squared minus 5 plus I z plus 8 plus I equals 0, and hence write that in factored form. So this is complex coefficients. And that means that the complex conjugate theorem, as we've just spoken about, that's theorem written really poorly. Let's try that again. Theorem does not hold. So the complex conjugate theorem does not hold. Hold on a second. So we're going to solve this and then write it in factored form. So the best way, again, our fallback, because I really, quite frankly, I don't want to try and factorize this. So our fallback is to either use the completing the square or the quadratic formula. So I'm going to go to the quadratic formula to this and see how we go. In the quadratic formula, I get A is equal to 1, B is equal to negative 5 plus I, and C is equal to 8 plus I. And so I'm going to go through and solve this now using that information. Z is equal to negative B, which is negative 5 plus I, plus or minus the square root of B squared, which is negative 5 plus I squared. That doesn't look much like an I, but let's try that again. There we go. That doesn't look much like a squared either. Minus 4 times A times C. So this is going to potentially get a bit out of hand, but we'll talk about how we can do this. 2 times 1, and I get from that 5 plus I plus or minus square root of negative 5 plus I squared is the same as just 5 plus I squared, which hopefully you can see gives me 25 plus 10I plus I squared, and then from that I've got negative 32 minus 4I. The expansion of the second bit. I'll just zoom in on this bit now. And over 2. This is equal to 5 plus I plus or minus the square root of 25 minus 1 from the I squared minus 32 gives me negative 8. And then 10I minus 4I gives me plus 6I. Probably didn't need the bar that long. All over 2. Now, I know from experience that that is the beginnings of a Pythagorean triple, which means it probably is going to give me something nice as a result. So I'm going to reflect on the question now. There are 2 things I'm looking for if I get a question like this in the exam. First of all, is this question worth 3, 4, 5 marks, or is it worth 8, 9, 10 marks? If it's worth 3, 4, 5 marks, then there's probably an allowance for me to use some technology. And at this point, the question's not really testing my square root skills on a complex number, so I would probably skip to technology now. The second thing is I'm looking for the words use analytical methods, because if it says use analytical methods, it means do it pen on paper, in which case I have to now calculate that square root. If I go back to the question, it doesn't say use analytical methods, but this is me showing as much pen on paper working as I can, not just going straight to the calculator, as much pen on paper method working as I can to solve this as far as I can. So you could do that square root if you wanted to. I'm going to choose not to. I got 5 plus I plus or minus, and I'm going to do the square root on here. If you want to use complex numbers on your graphics calculator, you have to make sure that your settings, shift setup, are in complex form. So if you shoot down the settings, complex mode, and at the moment I've got mine in real, I'm going to put it into A plus BI, and then I'm going to calculate shift the square root of negative 8 plus 6 times I, and the I is above the 0. 6I, because I've got to use a special I, and it tells me that the answer is 1 plus 3I. Over 2, and so now I can compute that. This is in brackets, gives me 5 plus I plus 1 plus 3I over 2, or 5 plus I minus 1 plus 3I. over 2. 6 plus 4i is what? 3 plus 2i. And 4 minus 2i is 2 minus I. They're my two solutions. Oh, yeah, I can do. I'll just finish the question. So therefore, I'd say that z squared minus 5 plus I, z plus 8 plus I, they were the right numbers, weren't they? Yep. Is equal to z minus 3 plus 2i, z minus 2 minus I. And you see the complex conjugate theorem doesn't hold in this case because I had complex coefficients. So I've got to be careful with that. But there's the answer. And as an aside, I've been asked to show over here, I'll do it in blue, why the square root of negative 8 plus 6i is equal to 3 plus 2i or 2 minus I. So I'll go through this process with you now. So to do this analytically, you need to start by making the assumption. It's going to end up in simultaneous equations because we have two solutions. Make the assumption that this is equal to something like that. And then square both sides. When I square both sides, I get a squared plus 2abi plus bi squared. And that becomes a squared minus b squared plus 2abi. And that leads to the fact that this is the real component and that's the real component. And this is the complex component and that's the imaginary component. And this is the imaginary component. And so I get negative 8 equals a squared plus b squared. And 6 is equal to 2ab. So say that again. X minus b squared. It is minus a minus b. A squared minus b squared is right, yep. So I've got that. And I can say therefore that b is equal to 6 over 2a, which is 3 over a. I can put that into number 1, which gives me negative 8 is equal to a squared minus 3 over a squared. So negative 8 is equal to a squared minus 9 over a squared. That's 9 over 9 squared, really. And then I can multiply everything by a squared. I get negative 8a squared equals a to the power 4 minus 9. This comes out as a quadratic, so I shift everything across. I get a to the power 4 plus 8a squared minus 9 equals 0. No, I actually get 4 answers out of this, but I've got a quadratic now, which gives me 2 answers. And then I end up with a plus minus, I can get 2 answers for my other one as well. So what I need to just make the point of here is that at this stage, I'm going to assume that A and B are both real numbers. Because in our complex system, we've always got A and B are real numbers. When I make that assumption, when I get down to here, you'll find how this works. So I've got a quartic. A could be 4 different things. So it gives me A squared plus 9, A squared minus 1. If you're not sure how to do that, you can do the substitution, let y equal A squared, and it makes it look more like a quadratic and easier to work with. And that gives me a squared equals negative 9, or a squared equals 1. A equals 3i, plus or minus, or a equals plus or minus 1. I don't care about the imaginary bit because I know that a is real. I made that statement at the start. If a is plus or minus 1, b is equal to 3 over a, which equals plus or minus 3. And therefore, where am I at? Looks like I should get another one here. A is equal, oh, sorry, not A. Z is equal to, no, maybe I do need to use that A. No. 1 plus 3i, or negative 1 plus 3i. that. I get the same answer there. What answer do we get over here? 2 minus I. Where's that come from? So? Oh, yeah. Okay, yeah, I see. Yes, that's right. Then we, yeah. Okay, got it. Then we put that or that into here, and that gives us 3 plus 2i or 2 minus I. Is that all right? Good. Just another moment on a video where I've got myself lost. So that's a pretty nice procedure, but this takes a while. You need to know the few things that take a while. Your exams are going to be time pressured. You need to understand marks and how many allocate on things and the use of the word analytical. This is for IA2 and 3, by the way. In the external exam, if that was in a tech active paper, I would just do that square root, bam. Like it's in tech active. They're expecting you to use technology. So if it's in a tech 3 paper, though, you obviously have to do that. Should be. So here's a summary from your textbook, and this is a summary of math methods again. When we divide a polynomial pz by a polynomial dz, we obtain 2 polynomials, a quotient and a remainder. It looks like this. If the remainder equals 0, then dz is a factor, etc., etc. Remainder theorem, factor theorem, and conjugate root theorem, they're all in your textbooks. So you can make a summary of that as well if you want to. And I've got some other examples. So this is the step up now is either you're solving quadratics with complex coefficients, that's about as hard as it gets, which is the one we just did, or you're solving cubics or quartics with real coefficients. I won't give you a cubic with complex coefficients unless I also give you a bunch of information like it has a factor of this or it has a root of this or something like that. So I've got example 5, tech free, solve that, oversee without using technology. And I might actually give you a minute to have a go at that.